Hello, welcome to our math class. I'm so happy you are safe and thank God that we are safe. Are you excited with our math class? Let's start our lesson. Maybe you're aware of this term polynomials, and somehow you have seen and discussed this already in your other lesson. Let's recap. And then we must identify also base, coefficient, and then the terms, also exponents in a polynomial. Let's describe algebraic expression where that each term is constant, a variable, or product of constant and variable. Giving emphasis that exponent must not be negative. And also, let's have the sign for constant, this one, because it's connected with number. And also, this one is the sign for variable, because for the concept of alphabet, A, B, C, and so on, and any letter. The three of these that you can see are all examples of polynomials. And even the third example that you can see an equal symbol, that's supposed to be also a polynomial. What is this term? Do you know this one? Term. So it is a constant or it is a variable, or it could be a product of the constant and then the variable. Here on the first example, we have here a trinomial expression, 3x squared plus x minus 7. Those consist of three terms. So that is 3x squared, another is x, another is negative 7. It is three terms. So let's find the terms of this polynomial. We have the first term, it's 5x squared. And then the second term, negative 6x. The third is positive 3. Second example, x squared. That's the first term. Negative 4x, second. And then negative 7, third. Another one, negative 3x squared plus x minus 6. The first term here is negative 3x squared, followed by the second term, positive x. And in the third term, it is negative 6. Wow! Let's define clearly what is numerical coefficient. So it is naturally constant or it is a number. While this one, the literal coefficient, it is the variable including its exponent. Then this one, as you can see, it's the constant. It is a term without variable. So going back with our separation of each term so that you can see clearly how terms involved in any polynomial. So you have 3x squared, you have there, as you can see, x, and you have negative 7. So circular, again, let's go back. What about this circular here? That 3 there is the numerical coefficient, and then followed x squared, that is the literal coefficient. Next, so it is 1 as the numerical coefficient, and then x it is literal coefficient. So look carefully and look closely. From the original expression, it's just x. So you, as junior high school, you must already aware that x there has a corresponding numerical coefficient if variable doesn't exist, not appear. Here, that is 1x, but to write it, it's just x. Then follow the circular, here is the negative 7. Yes, that's the constant. In this expression, let's determine and answer the numerical coefficient and what is the literal coefficient, and also what are those constants. So, first example is 5x squared. Obviously, that 5 there, yes, it's the numerical coefficient. And then x squared, that's supposed to be, that is the literal coefficient. Next, negative 6x for the second term. So the numerical coefficient is negative 6. Negative 6. And x will be the literal coefficient. The constant there is positive 3. Wow. You have already gained it more easily. Okay, let's go now to the second polynomial. X squared minus 4x minus 7. So, what do you think will be the numerical coefficient here in x squared? Answer, what? Best. Correct. That is 1. Okay. 1. 1 will be the numerical coefficient for the first term. Imagining that, imagining it is 1x squared. For the second term, negative 4x is the numerical coefficient, followed by x, which is the literal coefficient. And then we have negative 7 as the constant. So third example. So this is more easier for you now. I believe so. We have numerical coefficient negative 3, then its literal coefficient, it's x squared. Now, second term, this one, second term, positive x. So, do you have any idea what will be the numerical coefficient? Definitely true, it is 1 as the numerical coefficient. Then x is its literal coefficient, and then constant negative 6. Wow, great. We learned about this one, parts and the components involving polynomials. Next, the next lesson connected with this is the product with monomials. So here, product with monomials. So we sign monomials MO. Okay. Product with monomials. It is important that discussing and answering about monomials and binomials and also trinomials. It's included the laws of exponent. So you must be skilled and be aware of all the laws of exponent. So you can see there the product rule for exponent. So observe, okay, the expression and then the second expression. Immediately obvious, we have x, and then the other symbol, it has also an x. So, to describe that, multiplying the powers which having the same base, stay and keep the base, and then you just add the exponent. So that's why if you can see there, that's xm. Then the other one is x raised to the n power. Now the resulting expression, some example, is x m plus n. Another law of exponent is the power rule for exponent. So here, you can see just one single expression inside. So where the base and the exponent is raised with another power. X raised to the m raised to the n power. Describe this one in finding power of a power. Stay and keep the base and then multiply the exponent. As what you have seen in the symbol of exponent upward. The resulting symbol expression here is x m n. Another law is the power of a product rule. So what did you observe with the base enclosed with open and close parentheses. It is now more expanded, not only one base. Obviously, the base there is x, y. In finding the power of a product, first find the power of each factor inside of that open and close parentheses, and then multiply that resulting powers. As what you have seen in the enclosed sample, xy raised to the m power, the answer resulting to x raised to the m power y raised to the m power. Excited of another examples here? So how are you? Just stay there, hang on, and just be excited to learn. So here we have three monomials: x raised to the 6th power, x cubed, and then x. So we apply the product rule for exponent. X raised to the 6th power, x cubed, and then x. So as you observe, obviously the x, which is the base there, was stayed and kept. And then what we move now is the exponent only. 6 plus 3 plus 1. So the resulting power is x raised to the 10th power. Wow. Another expression, x to the 5th power y cubed, then x to the 4th power y raised to the 5th power. So we use the product rule for exponent in each base. Look closely what happened with x base. Look closely also what happened with y base. Yes, it just stayed, and then just combine all the exponent group for x base and combine all the exponent group for the y base. So the resulting expression is x raised to the 9th power, y raised to the 8th power. Wow, we have learned more. Next expression, again, it has 7b and another negative 5b squared c cubed, another 2b. So we use the product rule for each base and also together apply the commutative and the associative property of multiplication. So observe and independently look at it. We have negative 5b squared c cubed, where numerical coefficient is negative 5. For 7b, we have 7 as a numerical coefficient. And then for another 2b2, 2 is the numerical coefficient. So we just group all the numerical coefficient and then group also all the literal coefficient corresponding with the same base. So you have 7 times negative 5 times 2. You can see there, okay? And then b, exponent of 1 added 2 added 3. And then since c cubed, there's nothing more of C base along all the expression. We just kept C cube as it is. So the resulting answer will be negative 70b raised to the 6th power C or C cube. So that ends our lesson now. See you on our lesson on factoring, and then happy learning. So always be excited and be in love with math. Bye!